Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded Module 1 to Module 3 videos in my channel. If you have not watched, please do watch them in my channel. And in Module 4 also, I have already completed first chapter. In second chapter, we are only left with the last topic. That topic we are going to see in this video. I've already completed concepts of stability, necessary conditions for stability, root stability criterion. Now the last topic of this module, module 4, and the last topic of this chapter, stability analysis, is relative stability analysis. And there are some problems also on this. We will see them in this video. Relative stability analysis. First we will see what it is. Once a system is found to be stable, the relative stability of the system can be determined quantitatively by finding the settling time of the dominant roots of the characteristic equation. What it means is, once you know the system is stable, then you can find the relative stability of the system by quantitatively. Quantitatively means what? Using values based on the values. Quantitatively by finding the settling time of the dominant roots, which are the dominant roots of the characteristic equation. The settling time of the dominant roots of the characteristic equation. Since the settling time is inversely proportional to the real part of the dominant roots. Settling time is what? Inversely proportional to the real part of the dominant roots. The relative stability can be specified by requiring that all the roots of the characteristic equation be more negative than certain value. All the roots must lie to the left of s, that is equals to minus s1 greater than 0. So it should be left side of the plane. Why? Then only the system is stable, as we know. The characteristic equation of the system under study is then modified by shifting the origin of the s-plane to s is equals to minus sigma 1. By substitution, s is equals to z minus sigma 1. In place of s, you will substitute z minus sigma 1. Z minus sigma 1. If the new characteristic equation in Z satisfies the root criterion, it implies that all roots of the original characteristic equation are more negative than sigma 1. What they are telling is, if the new characteristic equation, you will get a new characteristic equation by substituting s is equals to z minus sigma 1. Then if that z satisfies the root criterion, it implies what? That roots of the original characteristic equation, the initial characteristic equation, that is in terms of s, are more negative than sigma 1. This s is more negative than sigma 1. Shows the relative stability for various root locations in S-plane. These are the relative stability for various root locations. If you see some different root locations, how the S-plane looks. And even those points are mapped into the signal. And this is also one more which is shown. Okay. Using this is what? The j omega means what? Imaginary axis. Sigma is what? The planar. Sigma plane. We will see problems now. Check whether all the roots of the characteristic equation have real parts more negative than minus 1 or not. They are asking for the characteristic equation have more negative than minus 1 or not. Here minus 1 is what? Sigma 1. Sigma 1 is equals to minus 1. Okay, what we have seen in the previous. So what we should do in this characteristic equation, you need to substitute z minus sigma 1. No, s is equals to z minus sigma 1. As you know, z minus sigma 1 is 1 minus 1. So z minus 1 you need to substitute. Okay, z minus 1 you need to substitute in yes. So that is what is written in this sentences, that to check whether all the roots of the given characteristic equation have real part more than 1 minus 1, So shift the origin of the S-plane. S is equals to -1. By substituting S is equals to Z minus 1 in the characteristic equation. Then if you substitute in the characteristic equation Z minus 1, what you will get? Z minus 1 whole cube. 5 into Z minus 1 whole square. 25 into Z minus 1 plus 30 equals to 0. So this is in the form of A minus B whole cube. A cube plus B cube minus 3A square B plus 3AB square. You will write in the A minus B whole cube formula. Then you will write A minus B whole square. A square plus B square minus 2AB. And A 25 into Z minus 1 plus 30. If you simplify this equation, you will get a characteristic equation in terms of what? In terms of what? Z. So for this Z, you are going to write root array. How you will write? The initial one will be the highest value. So Z cube, Z square, Z1, Z0, and the coefficients are 1, 2, 18 and 9. How we will calculate? 2 into 18 minus 1 into 9 by 2 is equals to 13.5. For the next array, we have to calculate 13.5 into 9 minus 2 into 0 by 9 by 13.5 into 9 minus 2 into 0 by, not 9 it is, I'm sorry, it is 13.5. Why? Because what we are multiplying? 13.5 into 9 into 2 into 0 minus 2 into 0 by 13.5. As you can see, this becomes 0. This becomes 0. So 13.5 get cancelled. You are left with 9. So you got, if you see, the first column of the root array is positive. All the elements in the first of the root array are positive. This indicates that all the roots of the characteristic equation in the Z lie in left half of the S-plane. In Z, characteristic equation in terms of Z, all the roots lie where? Left half of the S-plane. Why? Because all the first column values are positive. This means the roots are on the left half of the Z-plane, which implies that all the roots of the original characteristic equation, that is in S, which is in terms of S, lie to the left half of the S, that is equals to -1 in the S-plane. S is equals to -1 in the S-plane. Why? Because they have given -1. S-plane. That is, all the roots of the characteristic equation in S have real parts. This means what? All the real parts have more than -1. All the real parts have more negative than -1. We have checked that it is correct. Okay. Next question. Determine the range of values of k greater than 0 such that the characteristic equation has roots more negative than S is equals to -1. Same way, what we have done in the previous, what you should do? S is equals to Z minus 1. You will apply. When you apply, you will get some value. After simplification, you will get as Z cube plus Z square 3k plus Z into k plus 2 plus 4 is equals to 0. So this one you will write in the form of root array: Z cube, Z square, Z1 and Z power 0. Then you will write the coefficients 1, 3k, k plus 2 and 4. We need to find the value of k here now. The range of k. So how? 1 into 4, 3k into k plus 2 minus 1 into 4. You will get by 3k. Then 3k into k plus 2 minus 4 by 3k into 4 by 3k into 0. How much you will get if you multiply these two and 3k into 0, if you minus both and divide it by this value, then you lastly will be left with the value 4. Okay. If you see the first column, we don't know whether it will be positive or negative. Why? Because we don't know the k value. First, we should find the k value. For the system to be stable, all the elements in the first root column must be what? Positive. From the Z square row, if you see, the 3k is what? Greater than 0. The k will be greater than 0. Okay. Then, from Z1 row, if you see 3k square plus 6k minus 4. If you multiply this 3k inside, minus 4 is greater than 0. If you take, then if you this 3k will go to right side, it will become 0. Then 3k square plus 6k minus k. Then the value of k you will get as what? Get as what? 0.527. 0.527. This you can do using the calci, using the degree value, so that you can easily get the k value, or else you can find using roots, that is plus or minus minus b plus or minus square root of b square minus 4ac by 2a you can do. Then you can easily get the k value. The k value is what? 0.527. Then from this the range is what? The k is greater than 0 and k is what? Greater than 0.527. So k will be greater than 0.527 and k is less than infinity. K is less than infinity. The range of k values for the roots of the characteristic equation to have real parts more than minus 1. To have the roots more than minus 1, the k value should be what? K value should be what? 0.527 less than k less than infinity. Right? Then determine if the pole nearest to the imaginary axis is at least minus 0.75 away from imaginary axis for the system given by the characteristic equation. See, they are giving here little bit to confuse you. Pole nearest to the imaginary axis at least 0.75 away means what? It is shifting from origin to the away, it is shifting from the origin to the some point, that is minus 0.75. So in the place of s what you should do, z minus 0.75 you need to substitute. When you substitute that, okay, when you substitute that values in this equation, then you can simplify into final z equation in terms of z. For that what you should do, you need to write the root array. But before writing to root array, as the system is unstable, you know that system, since some of the coefficients of these characteristic equations are negative, it can be concluded that some roots of the right half of the z plane to the right of s, that is minus 0.75 in the s plane. Hence the pole nearest to the origin is less than minus 0.7 away from the imaginary axis. Hence the pole nearest to the origin is less than minus 0.75. So what it means that to find the poles to right of the s, right of s is equals to minus 0.75, you need to formulate the root table. So root table is same, 1 minus 2, 11.24 minus 5, this, and you will do multiplication and divide it with the values. The same procedure for the root array. In this also I've repeated. If you want to know how to do root criterion problems or root array, in the previous video I've already done very clearly. You can go and check out my video. Then after this, if you see, looking at the elements of the first column, there are three sign changes. See, minus, plus 2 minus, minus 2 plus, plus 2 minus. So three sign changes. Hence there are three roots of the characteristic equation have real parts less than minus 0.75. There are three which are minus 0.75. You need to write in this way only, line. Okay, so try to understand how to write the sentences. Like there are three sign changes. So what it means? There are three roots of the characteristic equation having real parts less negative than what? Minus 0.75. Should write like this. Then determine whether the largest time constant of the characteristic equation given below is greater than, less than, or equals to 1 second. So they are given the characteristic equation. They are asking us to find whether it is greater than, less than, or equals to 1 second. The last time constant of the characteristic equation is either 1, less than 1, or greater than 1. They are asking. So the characteristic equation is this. First we will find the time constant. Okay, the time constant associated with the characteristic equation is how to find. I'll show here. See this side. Try s is equals to minus 2 initially. When you put s is equals to minus 2 to the equation, then you will get as 0. So the s plus 2 will become as one of the factor. Then in the same way how we have done in the previous videos, this the main characteristic equation needs to be divided by s plus 2. So you will get s square plus 2s plus 2 as the quotient. That can be multiplied with s plus 2. So these two, and s square plus 2s plus 2, again you need to take the roots for this. But before taking roots, if you compare this s square plus 2s plus 2, it is similar to the characteristic equation, the second order. The second order time response equation is there. No, for that s square plus 2 xi omega n s plus omega n square. On this also I did problems. If you see here, 2 omega n here is compared with 2 here equals to 2. Same, no? So equations look same. So then that is equals to 0 actually. Okay, then omega n square is what? Is 2. So omega n will become root 2. So 2 xi root 2. 2 xi root 2 is equals to what? 2. You substitute omega n into the previous equation. Then xi will become what? Xi will become what? 1 by root 2. That is equals to 0.707. You got the xi value. The time constant formula is what? 1 by xi omega n. You need to remember this formula. Time constant is equal to 1 by xi omega n. 1 by xi omega n is equal to what? 1 by, you got xi value as 1 by root 2 and omega n is root 2. Finally 1 by 1, that is 1 second is the time constant. So you got time constant 1 second. How you got to know, right? I have written, it is directly written in the textbook as tau is equal to 1 second. So to make you understand, I did it separately in the right side. You can check again, so that you can understand clearly why that 1 second has come. So we have to determine whether the roots of the characteristic equation have real parts greater than, less than or equals to -1, which is asked by the question. So for this, put z is equals to, s is equals to z minus 1. Why? Because we got 1 as the value, 1 second. No, what they asked, whether greater than, less than or equals to 1. So it should be greater than, less than or equals to -1. Nothing much. Okay, so s will put as z minus 1. In the place of s, the characteristic equation, same like the previous questions, you will put z minus 1 in the value. Then you will get a characteristic equation. For that characteristic equation, you will get the roots table. For the roots table, you will multiply in the same way, that is 1 into 1 minus 1 into 1 by 1. You will get 0 and again another 0. So if you know, in the root criterion, already I have solved like this problems. If whole row is 0 and 0, what we should do? The previous row is there, no? From that previous row, the 0, 0 which has happened, for that row, previous row will be there, no? For that row, you need to write auxiliary equation. How to write? Z square plus z power 0. As the coefficients are 1 into z square plus 1 into z power 0. So it will become z square plus 1. See, auxiliary equation. I have told previously only because you will understand clearly. So z square plus 1 is equal to 0. Then now you will differentiate this. If you differentiate, you will get 2z is equal to 0. You need to substitute in place of zeros the auxiliary equation. 2 to this and 0 plus 0. There is no constant, so 0. So again you need to multiply 2 into 1 minus 1 into 0 by 2. 2 by 2 you will get as 1. Looking at the modified root table, what you can see that all the elements in the first column of the root there are same sign. They are all same sign. So there are no roots of this modified characteristic equation to the right of s minus 1. That is to the right of z is equal to 0. Since there is a row of zeros, the roots on the imaginary axis at s is equal to -1. In fact, the roots are s is equal to -1 plus j1 and s is equal to -1 minus j1. So the largest time constant of the characteristic equation is 1 second, equals to what? 1 second. Okay. See, what they have done here is that first they have found the roots. First they have found the characteristic equation. They have took the time constant. So in the place of s, they have substituted z minus 1. After substituting z minus 1, you got some problem with y because the rows are 0. So when you substituted the auxiliary equation, then all the first column are positive. So there are no sign changes. So what it means? There are no roots on the right half of the s plane. So what it means that the roots are on the imaginary axis. The roots are on the imaginary axis at s is equal to -1. So the roots are what? S is equal to -1 plus j1. S is equal to -1 minus j1. So the largest time constant of the characteristic equation is equal to what? 1 second itself. 1 second itself. So these roots, I've told already how to find roots in the previous video about when doing root criterion, how to find these roots. You can follow my previous video if you have not, if you will not understand. So these two roots you will get when you solve using the characteristic equation. So those two roots you can find, and the time constant is equal to nothing but 1 second only, as there are no roots on the right plane. Okay. So by this we have completed the module 4 successfully, and the module 4 first chapter and second chapter is done till relative stability analysis. So if you have any doubt, you can please put in the comment box. I'll help out. I'll try to help out, or I will do some another video if you have any doubt based on the topics which I'm covering. If you want any extra information also, you can just put the message in the comment box. By this, module 4 is done. Module 4 is done with the time response analysis and stability analysis. With the module 5, I will upload a new video next. For now, I'm stopping the video. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.